Welcome back, Algebra 1. So today we're going to be working with the Pythagorean Theorem. The Pythagorean Theorem is just a way that we have, when we know two sides of a right triangle, it's a way we have to figure out what the third side is. And believe it or not, this is actually going to be really handy. It's got lots of applications, everything from construction to engineering. There's a lot of ways that we can use this. So let's jump into it and let's try and figure out what this is all about. Now, down here in the corner, you see the Pythagorean theorem written out. And before we start working with it, I want to manipulate it just a little bit using what we know about algebra. Okay, so let's say that we know what A and B are and we want to just solve this for C. Well, how would we do that? We know that to solve something for a variable, we just have to do the opposite to both sides. And the opposite of square is square root. All right, so the way, if we're solving this for C, what we'd actually do is just A squared plus B squared, and then get that total, so equals, and then take the square root of it. All right, let's say that we wanted to solve for A squared. Well, again, we know how to do that. Just subtract B squared. And then the next thing that we would do is take the square root of both sides. So in order to solve for A, what we'd really do is C squared minus B squared equals square rooted. So that algebraically, I don't want to have to kind of labor through all of that every time. So here's what we're going to do. Pythagorean theorem is A squared plus B squared equals C squared. How are we going to use it? We're going to think about it just like this. Something squared, and then either plus or minus something else squared equals square rooted, and we'll have our answer. Let's see what I mean by this. All right, so I'm looking at this first triangle up here in the top, and what I'm always going to do, I'm always going to write it in there. Maybe you just want to imagine it, but I imagine a plus being right there in that right angle. Okay, so here's what I've got. Since both of my numbers, the 9 and the 4, since those two sides are touching the plus, this is going to be a plus problem. So how are we going to enter this on our calculator? 9 squared plus 4 squared equals square rooted. And let's see what that is. That's all we're going to have to do. 9 squared plus 4 squared equals square rooted. And that's going to be 9.85. 9.85. That means that this side right here, this side C, is actually 9.85. Let's look at the bottom one. Again, I'm going to put a plus right here in my right angle sign. And so this is going to be a plus problem since both 72 and 21, since both of those sides are touching that plus, this is going to be a plus. So all I have to do is take 72 squared plus 21 squared equals square rooted. And let's see what that comes out to be. 72 squared plus 21 squared equals square root that, and let's see what we've got. This side is going to be 75. So this side up here is 75. Our answer is 75. Let's do another one. Okay, so once again, I'm going to think about there being a plus in this right angle. Now look at what we have. We have this side over here does not touch the plus. All right, it's not touching the plus. So if it's not a plus, what's it going to be? It's going to be a minus. All right, so one thing we're going to do here, make sure we're always using the bigger number first. Otherwise, we're going to get some tricky stuff later. But 33 squared minus 29 squared equals square rooted. And let's see what that is. 33 squared minus 29 squared equals square rooted. And that's going to be 15.75. 15.75. Now, if you're working through this on your calculator, you might have got some crazy answer like 2 square root of 62. For right now, let's just change that to a decimal and put it as 15.75. Let's look at this bottom one. Again, I'm going to put a plus in there, and this 34, that side is not touching the plus. So if it's not touching plus, it's going to be a minus. 34 squared minus 16 squared equals square rooted. And let's see, 34 squared minus 16 squared equals square rooted, and that's going to be an even 30. So our missing side, right down here, side B, is 30. Okay, that's not bad at all. Let's do a couple more. Let's try to mix it up and see what we've got. So put a plus in the right angle. So I'm asking you, is this going to be a plus or a minus problem? Addition or subtraction? This is going to be subtraction because this 6.5 doesn't touch the plus. So what is 6.5 squared minus 2.7 squared equals square rooted? Let's see what that is. 6.5 squared minus 2.7 squared equals square root 5.91. That's the length of this missing side. 5.91. Let's look at the bottom. Which one is this one going to be? Well, put a plus right there. Both the 6 and the 2 are touching this side, so this is going to be an addition problem. So all we have to do is 6 squared plus 2 squared equals square rooted, and that is going to be 6.32. 6 squared plus 2 squared equals square rooted, and that's going to be 6.32. All right, now let's look at this. So this is an interesting idea, the Pythagorean triple. So we've got 3 numbers right here, and I want to know if they make a right triangle. So if we have a triangle with sides 16, 28, and 32, what I want to know is this a right triangle? Well, let's just use the Pythagorean theorem. And this is just going to be an addition problem. 16 squared plus 28 squared equals square rooted, and let's see what we get. 16 squared plus 28 squared equals square rooted, and that answer is 32.25. 32.25. What that means is, if this were a right triangle, the Pythagorean theorem said that that would have to be 32.25. That's not the same thing as 32. So, do these numbers make a Pythagorean triple? Do they make a right triangle? No, they do not. That is not a Pythagorean triple. Let's try the next one. So we'll just say 15 squared plus 36 squared equals square rooted, and let's see what we get. 15 squared plus 36 squared equals square rooted, and that's going to be 39, which is what we got right there. So these make a right triangle. That is a Pythagorean triple. How about this one? 4 squared plus 5 squared equals square rooted. Let's see if we get 6 there, if that's a Pythagorean triple. 4 squared plus 5 squared equals square rooted, and that is going to be 6.4. 6.4. So is this a Pythagorean triple? No, it is not. That does not make a right triangle. Okay? Next couple lessons, we're going to get into ways that we can use this, we can apply this, and I think it's going to be a lot of fun. All right, so I know you can do this. Good luck.